Architectural technology and detailing, tutorial number 6. Today I want to focus on some of the heating and cooling systems. Okay, so we spoke about the options of using, there's a number of options that we looked at. So of course, if you're dealing with someone who needs to have some human comfort, of course you have got a different kind of annual kind of temperature that deals with in winter is different to summer, or let's rather make it like this, where the temperatures, if this was temperature, that if this was the temperature gauge, that this would be summer and this would be winter. So because of the changing temperature across the year in months, the way that you experience the internal environment will change. So naturally in summer, this pen's too thick. In summer, when the sun is really high and you're at about 88 or 89 degrees, you're going to experience sort of ambient heat everywhere. In Johannesburg at night it's also hot, so you don't really need to deal with, you don't need that kind of heat, so you want to get rid of that heat. What that normally requires is two type of strategies. Is that in summer conditions you want to reduce the amount of heat that comes through that window, any kind of window, so that heat doesn't happen on the inside. But also the type of heat that sits on top of the building is also problematic. So one way of dealing with that strategy is to, of course, have overhangs that cannot allow the heat or the sun to get direct access to that space. But also, if you got a roof garden, your roof garden will ultimately give you some of that foliage that you need to protect thermally against the hot sun. What one tends to do is, so firstly shading, and then the second thing is to allow heat to escape. Of course, heat travels upwards, so the idea is that you could allow heat to escape vertically. When wind comes through, that creates a positive pressure, and what happens is if there is heat build up on the inside of a space, you will find that it will create a negative pressure over here, which means that because air tends to equalize, it will draw hot air out of that space. So a vertical kind of a chimney of sorts works really well. So that is strategy number 1, which deals with reducing heat. This is a summer strategy. Number 2, another strategy is reducing heat or blocking heat. The second strategy is to get rid of the heat. That would be another strategy. A third strategy of that is if you had some kind of pump inside of that, so a fan would extract heat. So these three combinations would help you reduce the heat and create better comfort. So what happens in winter? So in winter, what you want to do is you actually want some sun, believe it or not, to enter a space. But you do not want the discomfort of working on samples or on a computer and have that sun be on top of your space. You don't want that. But what you can have is when heat builds up on a surface, that rising heat can move through the space and warm up that space. You just want to create a separation between where that heat happens. In winter, you actually want the heat to build up onto your structure, but of course you cannot take away your foliage and remove your foliage. But what you can also do is you can, if you had louvers in a space, you could then close that louvers so that the heat buildup could remain in the structure. Thermally insulating your building as well helps to retain that heat. And if you had some kind of vertical stack of sorts and the wind pressure creates a vacuum so that it gets extracted, you could perhaps find a way to close that off. So that's a typical winter strategy. But now what we were talking about is something slightly different. In addition to this, we spoke about the idea that in winter, I'm going to delete these layers. So let's talk about the west side. This is west. The sun is baking on this end. So the strategy works. It doesn't work in summer because you don't want that heat. What you want in winter is you want this heat to sit on that wall. And there's a number of strategies we can look at. So the one is sort of passive. Passive core tempering. By that I mean whatever heat sits on this facade and whatever sits on that facade along after the last few hours of that day, the idea is that that heat in section, let's draw the west side, winter time, can over time, over the next couple of hours, I don't know the exact duration, so I've never worked it out, but what you get is in wintertime, you would get this heat coming through. What that of course means, we spoke about it in the previous elective, in the previous tutorial, is you do not want massive openings on that side, but rather use that to heat up that space. So that's strategy number one. Sorry, I rewrote there. Another strategy is we spoke about if you captured the heat on the side in some kind of void or box. So say, for example, this roof or this end of the building, and say for example, formally you want to increase the height of that. It just looks better. That's where the aesthetics come from. If this thing bakes in the sun the whole day and it's made out of sheeting, steel sheeting, black. If it's black painted, it retains even more heat. And it's closed on top. What will happen in section is that heat would kind of sit inside of that. And the idea is that you would kind of take that heat at about 3 to 6 p.m. in the evenings on a winter day. Remember this, you can also do if you had a sheeted roof. Say that was a sheeted roof. And these are trusses. Same thing, principle applies. So anything that has some kind of void, and that heat gets in, you want to drag that heat through a pump down to the bottom. So if this is your concrete floor, you build a double concrete floor. It's like a double raft, and you pack this full of rocks. Say this is a floor. Someone sitting there. So you pack this full of rocks, and this pump or this pipe went into here, and all through the day you put this pump on, it keeps pumping into this. What will happen eventually is this will start to gain a bit of heat. Because the more density material you have, the more dense your material, the longer it retains that heat. Then what you do is at about 5 a.m. this goes on. There's a pump, the fan, and you start pumping the hot air into this space, and you arrive at say 6 p.m. You start extracting that heat, and this shuts off. What you then get is a pleasant environment in the morning. So that is a rock store strategy. 3. This is a geothermal concrete core tempering. Let's delete that. Let's delete that. And you've got a slab. that slab has got beams in it. In this case, you're not dealing with the sun, but you're dealing with the earth. And what we're going to do is we're going to dig a hole, take a frankie pile, go down by 100 meters, and we're going to run a PEX pipe through our slabs. Go up, run like a radiator. Then come down into a box, what they call a heat pump. And this gets looped all the way back into here and go start there. So it's what they call a closed system. Because it's not open, you don't use it anywhere else, and you close this ground up. What happens is at about 100 meters below the Earth's surface, you're sitting at about 35 degrees Celsius. If the Earth, say for example, above the Earth you're looking at 23, 27, anything around there. By the time you get down to the ground, I think it's 35 degrees Celsius, I'm not 100% sure. But what happens is the 35 degrees runs through in here, and then you add the heat pump at a very low energy consumption, adds on about 2 to, I'm not 100% sure, 205 degrees Celsius, and you're ending up going up to about 36, 37 degrees Celsius. What happens is you then can get that heat coming off the slab. And what happens is, because that PEX pipe is sitting inside, it's radiating heat. Water conducts heat faster and better than air. So it's the water inside of that's then making contact with the slab. And what you have is a heated up slab. So your experience is that you get much hotter air. Of course, you can find ways to intercept this so that you can close this off during summer time so you don't get that heat. Okay, I think those are your 3 options for strategies. I think there's a 4th strategy which you can explore just by thinking about the logic. If you had a water tank, and that water was linked, the problem with this was linked to your slab. The problem with this is that it's not an open source system, so you're going to lose energy. So unless you have a division, so your water tank can serve both water coming in from the river and as a separate element, as a separate body of water, it's heated by geothermal heating to heat up your floor. So your tank or gas can be split in between. Alright, I think that's enough for that little tutorial. Thank you.